Today's topic, what are we made of? Organic compounds. Now let's review. An atom is the basic unit of all things, the basic structure of everything. If we took that table and broke it down into its smallest pieces, it's an atom. The smallest things that are all together. An atom is made of protons, neutrons, and electrons. If we take two different atoms, and put them together, or combinations of two different atoms, or three different atoms, or more than that, two or more, we get a compound. Organic compounds are compounds of life. Now, this gets a little confusing for people because it's really small. We're talking in the really small here. But you're also going to see some terms that you've seen before and you've heard of before, so that'll maybe help a little bit. Let's start out by talking about what organic compounds are. We also use the term polymer, and we're going to come back to that. If you've been in plastics class, you know what a polymer is, okay? And this kind of has a kind of correlation between Mr. Klein's plastic class and this class. Okay, a polymer, an organic compound, contains atoms of carbon and hydrogen, along with others, but especially carbon and hydrogen. In every organic compound, you will find atoms of carbon and hydrogen. We talked in ecology, during the ecology unit, about the four major elements of life: carbon, hydrogen, oxygen, and nitrogen. The first three are very important to organic compound. Well, all four are important to organic compounds. The first three are in every organic compound, and the last one is in two others. So organic compounds are the structure of you. And you're like, well, I thought I was put together with bones. Yes, your bones and your muscles are made of these. We're getting small here. Okay, we're talking very small. Let's talk about why carbon. Carbon, we say that carbon, the element carbon. So all these atoms of carbon, we said that the most, back in the ecology unit, we said carbon is what you're made of. That's your basic element you're made of. Forms four stable covalent bonds with other atoms. So in other words, you have a carbon atom here, and it can form four bonds. I'm just going to draw a bunch of carbons. Let's say a hydrogen and an oxygen and an oxygen and an oxygen and a hydrogen and a hydrogen and an oxygen and a hydrogen. And so this enables carbon to be able to form chains. And an underlying theme of this set of notes is the idea of chains. That you're built of chains of compounds, strings of compounds. If you think of eating a steak is made of muscle. Muscle has all these strings in it. Those are strings, those are chains of protein. Okay? Carbon can form four stable covalent bonds. This enables it to form chains. And structures like the one on the last page, this ring structure. Okay, which you can see looks kind of like a block. All right, let's talk about polymers in general. First of all, a polymer is something, poly means many, mer means thing, many things. So a polymer is made of chains, there it is again, of smaller compounds. We call an individual part of a polymer a monomer. Monomer, one thing. So we can put chains, we can take these individual things and chain them together to make a polymer. Polymers are put together in a process called dehydration synthesis. Dehydration, to lose water. You probably already know that word. Hydrate, water, lose. Synthesis, create. So to create a polymer, we take these individuals and we remove a water molecule and they bond together. That forms a covalent, very stable bond together. It's called dehydration synthesis, which means water is removed. So to take 3 monomers and put them together, we have to remove 2 waters. To take 1, 2, 3, 4, 5, 6, 7, 8 monomers and put them together, we have to remove 1, 2, 3, 4, 5, 6, 7 water molecules. When we do that, they chain together. What about breaking them apart? I'll give you a quick example. When you eat, you break down or digest organic compounds. That's what you do. OC is organic compounds. This breakdown process is called hydrolysis because water is added to make it happen. And I apologize, this cuts off a little bit on this side of the slide. Here's a polymer. We add a water molecule. That makes this bond break. And now you have a 3 monomer. There are 3 monomers in this polymer, and here's our lonely guy who just got broken off. The term is hydrolysis. Now those 2 words are kind of hard. That's okay. We'll be talking about that again throughout the year, because when we come back to human digestion, we'll talk about how you break apart these polymers. All right. So now what we're going to do is we are going to talk about the 4 major organic compounds. Okay, and I should have put in a title slide for this part. There are 4 major organic compounds, and you want to write this into your notes, or somehow when you're doing your note-taking to make sure that this is what's coming next. And what I'm going to do, number 1 is protein. Protein its use. We use protein to build ourselves and to get energy out. If you think about a living thing, and we talk about the stuff it's made of, muscle, hair, blood, bones, all those, their structure is protein. When you are lifting weights for football and you want to get your muscles bigger, you eat protein. You will also use protein for energy. We'll talk about that a little bit later on when we talk about digestion. Protein is constructed of chains of things called amino acids. Chains of things called amino acids. Over here on the right are a whole bunch of amino acids. Okay? These are chains of protein. Those things, there are 22 different kinds of amino acids, and maybe you've been down to GNC or somewhere else and seen amino acids in a can. You can buy these. This is just their chemical structure. These are chained together to make a protein in different orders. Examples of protein you may have heard of: insulin, Insulin is a protein used by your body. It's a hormone produced by your pancreas, hopefully. Maybe one or two of you has diabetes, and that would make maybe somebody in this class or in another class with diabetes, they have to take this protein. You may have heard of collagen, stuff that makes your skin stretchy. Keratin is the stuff in your hair, makes your hair. Examples of protein. Organic compound number 2, carbohydrates. And you're starting to think, man, I've heard these words before. Yeah, you will see these words when we're talking about nutrition. These are things you have to eat. How many carbohydrates did you have today? How much protein did you have today? Carbohydrates are used mainly for energy. So they're used. They are chains of things called monosaccharides, which is a big word, which literally means single sugar. Monosaccharides are sugar molecules. Sugar molecules. Carbohydrate literally means carbon and water. Carbohydrate, if you count the atoms, 1, 2, 3, 4, 5, 6 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 hydrogen, and 6 oxygen. You see that there's a carbon, 2 times the number of hydrogens, and an oxygen. This number is twice that. That's the chemical formula for carbohydrate. Glucose, which we'll talk about over and over again, is the best known single sugar. I didn't want to write saccharide out again. Monosaccharide. Some examples of carbohydrate. Maybe you've heard of starch. Starch is a chain of carbohydrates. When you eat a potato, you're getting a lot of starch. That's because a potato is built with chains of these. And when you eat that, you're eating chains of sugar, literally. Lactose, maybe somebody in here is lactose intolerant. That's milk sugar. It's a different form of this. Third one. Fat. Fat. Scientific word. Lipid. There's some fat. Fat's used mainly for energy. Although, like in this guy, it's stored in packets. And it's also can be used for insulation and protection in your body. Sorry, I went too fast. You can pause the video. Fats are made of chains. Theme is chains. Something called fatty acid and glycerol. This over here just shows what a fatty acid looks like. Fatty acids are also known as hydrocarbons. We use that same word. We use the same word when we talk about gasoline as a hydrocarbon. Hydrocarbons can be used for fuel. They can be burnt. If you've ever made a grease fire at home, you know what this means. You've been burning fat. When I cook on the grill, sometimes the grease drips into the grill and starts burning. That's because these bonds, we're going to talk about this later when we talk about energy, are broken. There are 2 basic kinds of fat that we're going to talk about. Saturated fat is animal fat. Unsaturated fat is plant oil. And we use the word oil for liquid fat. Plant oils are liquid at room temperature. Let me go through a quick explanation of why. Some of you are going to find this extremely uninteresting, and some of you will find it really cool. If you look at the difference here between a saturated fat and an unsaturated fat down here, a saturated fat has this very linear structure. It's a line. That means at room temperature, when you let your bacon grease cool, that all of these molecules, I'm going to erase all the ink on this slide and draw this. All of these molecules can get very close together and stack to form what we would see that as then is a solid, because anytime molecules get really close together, it's a solid. In the case of unsaturated fat, it has this kind of kink structure. So when those molecules, when they they don't lay next to each other because they don't line up. So one might go that way, one might go this way, one might go over here. And so what happens is the molecules are farther apart, and maybe you learned this back in the day, that the molecules farther apart make something liquid. Water molecules in a bottle of water are farther apart than they are when they're in ice. And so there are two examples. These are examples of kinds of fat. Last one, nucleic acid. We're going to talk about nucleic acids in some great detail later on. You probably recognize that nucleic acids are used for your genetic code. They're made of chains of things called nucleotides, and we're going to talk about nucleotides later, so we're not going to go into great detail now. Example right here, DNA. You won't have to remember this. Deoxyribonucleic acid, DNA. RNA. For RNA, you just remove the deoxy. And that's the end of our notes on organic compounds today.